have you here with us in the end. I know you're right there too. Let's see. 7.2, y'all, talks about how we're going to do this idea of hypothesis testing. Okay. So let's see. It says, once again, the decision to reject or fail to reject the null hypothesis, y'all, depends on what we call the p value of the test statistic. So, decision rule based on a p-value. So it says to use a p-value to make a decision in a hypothesis test, we're going to compare the p-value with something we call alpha. If p is smaller than or equal to alpha, we're going to reject the null hypothesis. But if p is bigger than alpha, we're going to fail to reject. Okay. So now it says, here is the p-value for a hypothesis test. P is equal to 0.0237. What is our decision if the level of significance alpha is, and they gave us a couple of examples here, y'all. Let me get my pen going. Here we go. Okay, so y'all, this is usually what I do. P in this case, 0.0237, right? Alpha in the first case, 0.05, okay? Now, we want to know, is P smaller or bigger than alpha? Y'all, when you're doing something like this, I usually kind of line them up like this, where I put my decimal 0.0237 and then the alpha 0.05, because the easiest way to do it, look, here's the decimal, they're the same. The zeros are the same. Which number is smaller, 2 or 5? 2. So P is smaller than equal to alpha. We are going to reject the HO, right? Remember, that's what we called the null hypothesis. We called it the HO, right? Because it was easy to understand it that way. Okay. All right, y'all, I'm going to do the same thing again for part B. So look, for part B, I'm going to write 0.0237, but now my alpha is 0.01. So look, the points line up, the zeros line up. Is 2 smaller or bigger than 1? What do y'all think? Bigger, right? So P in this case, y'all, is bigger than alpha. If P is bigger than alpha, we are going to fail to reject the whole, okay? All right. So let me keep kind of going down, y'all. I'm going to show you how we're going to use these p-values in a few minutes, okay? But let's do this. We want to see if we can find the p-value for a hypothesis test, okay? So y'all, when we're going to find the p-value, this is what we're going to do. When we have a left tail test, P is going to be the area in the left part. In a right tail test, P is going to be the area in the right tail. But if we have a two-tail test, P is going to be equal to 2 times the area in the tail of the standardized test statistic. I'll show you what I mean by that, y'all. Okay, so look what it says here. It says, can we find a p-value for the left tail test with a test statistic of negative 2.33? Look, y'all, first thing I'm going to do here, my test statistic is negative 2.33. Remember, y'all, the number here is 0. That's a 1. That's a 2. That's a 3. That's a minus 1. That's a minus 2. That's a minus 3. The number that we have, y'all, right here is negative 2.23. What we're trying to do, y'all, we're trying to find the area to the left because it's a left tail test, okay? So y'all, remember how we're going to do this. The way we're going to find alpha is we're going to go normal CDF. Remember, we're looking for the area to the left. From negative 5,000 to a negative 2.23. So look, let me grab my calculator. Let me turn this guy on. Let's go second vars. Let's go to number 2, negative 5,000, right? Comma, negative 2 point, what is it, 23? Okay. All right. So y'all, I'm coming up with my alpha to be 0.0128. Now, y'all, just to give you a heads up, because I was going through the questions earlier, or my sorry, it's not my alpha, it's my p-value, sorry. That's my p-value. Okay. So my p-value here, y'all, was, what is it, 0.01? Would you say 28 or 29? 29, okay. 0.0129. Okay. So now, just like we did before, y'all, 0.0129. Our alpha here, 0.01. Okay. Now, let's start doing a little stare and compare. Look, we got our point. Okay. We got our 0. Those. Oh, look, we got our 1. Now, y'all, I don't see the number here. What would the number to the right of this be? A 0. Okay. Is 2 smaller or bigger than 0? Bigger. Okay. So look, y'all, P is bigger than alpha, right? If P is bigger than alpha, look, what does it say right up here? Sorry. If P is bigger than alpha, we're going to what? Fail to reject. Okay. So right here, y'all, I'm going to say we're going to fail to reject the whole. Okay. All right. Look, let's try another one like that just to make sure that we're okay. It says, can we find the p-value for a left-tailed hypothesis test with a test statistic of negative 1.71? Okay, so look, y'all, again, just a reminder, look, that's 0, 1, 2, 3, minus 1, minus 2, minus 3. The number that we are looking at, y'all, negative 1.71, somewhere right about here. And we're looking for that area, right? Okay, so look, let's find our p-value. We're going to go normal CDF, okay?
Is the p-value also the area, sir?
That's the area. That is the area. That's right. Very good. So, guys, remember the p-value is the area there, okay? So, look, let's do the same thing again. I'm going to just go second entry, but I'm going to change this to a negative, what is it, 1.71. Okay, let's hit enter. Okay, so, y'all, for P, 0.04, what do you think, 36 or 37? 36, okay. 0.0436, right? Okay, now let's do a little stare and compare. Okay. P 0.0436, alpha 0.05. Okay. So look, my points line up, my zeros line up. Is 4 smaller or bigger than 5? What do y'all think? Smaller, right? So look, y'all, P is smaller than or equal to alpha. So now we're going to reject the null hypothesis, okay? All right. So, y'all, I got another question here. It says, can we find the p-value for something we call a two-tailed test with a test statistic of 2.14? Decide whether to reject the null hypothesis if the level of significance alpha is 0.05. Okay, so the first thing I'm going to do, y'all, I'm going to scroll up here just so I can get everything here on my page. Just like we've been doing, y'all. Look, 0, 1, 2, 3, minus 1, minus 2, minus 3. Okay, look at the z-score they gave us, 2.14. That's 2.14. But y'all, they're telling me that this is going to be a two-tailed test. So look, y'all, I'm going to come down over here, negative 2.14. Okay. Now, what I'm trying to do, y'all, is I'm trying to find the area in the green spots. Okay. We're trying to find the area in the green. So there's a we can do this. If we wanted to find, say, let me do it like this just so you can see a little bit better. If I wanted to find the area in the light blue, and I was going to do normal CDF, where would I start? If I was trying to find this area over here, y'all. Good, negative 5,000. Awesome. Where would we stop? Negative, very good. Okay, let's do that, y'all. Let's see if we can find that. So look, let's go here, let's hit enter again. Let's change that to a 2.14, keep it negative, don't forget. Okay, are y'all coming up with 0.0161, all that kind of change? Okay, now y'all remember, we're actually looking for the area in both parts. Because the graph is symmetric, you know what we can do, y'all? We can multiply it by 2. And that's going to give me my p-value, because that area over here and that over there are going to be the same. But my p-value, though, y'all, is going to be, let's see, 0.03. What do you think? 23, 24? 20, what? 24. 0.03, 24. Okay. Now, let's do this again, y'all. 0.0324. Look at my alpha. My alpha is 0.05. So look, my decimals line up. Boom, my zeros line up. Is 3 smaller than or bigger than 5? Smaller. Okay, so look, y'all, P is less than or equal to alpha. And I'm just going to scroll back. Oh, look right here. We did it earlier. When P is smaller than or equal to alpha, we are going to, we're going to reject it, right? We're going to reject the null hypothesis, okay? Okay. Let me scroll down just a little bit further, y'all, down my list. And what we have here, y'all, is something called a z-test for the mean, okay? So we're going to find something, y'all, called the test statistic. And I think we did this before. Didn't we do this back like in chapter 5? Didn't we use that formula before in chapter 5? X minus mu divided by, I think we did this towards the end, y'all, like 5.4. We used that formula before, okay? So we're going to use this formula again, y'all. I'm going to show you how we're going to do it. Okay, when we're going to do p-values, okay, first we got to make sure that we know our population standard deviation. Samples got to be random and population normally distributed, or n is bigger than or equal to 30, okay? Then we're going to state the claim mathematically. We're going to find both the ho and the ha, okay? The null and the alternate. We're going to specify the level of significance. That's going to be my alpha, okay? We're going to find what we call our standardized test statistic. That's going to be using that formula right there, okay? And then once we find that standardized test statistic, y'all, we can find our p-value, okay? Again, if it's a left tail test, it's the area to the left. If it's a right tail test, it's the area to the right. And if it's a two tail test, remember, we're going to double it just like we did. Then we'll either make a decision to reject or fail and interpret the decision in terms of the original claim. Okay, so look, let's read through this question, y'all. I'm going to walk y'all through the process, okay? Let's go real slow here. A random sample of 89 eighth grade students on a national mathematics assessment test had a mean score of 267. The test result prompted a state school administrator to declare that the mean score for the state's eighth graders on this exam is more than 260. Assume that the population standard deviation is 34. At a 9% significance level, that's what 0.09 means. Is there enough evidence to support the administrator's claim? Okay, so let's go really slow here and let's see if we can figure some things out. Y'all, do we know how many eighth graders took that test? 89. Look, y'all, that's my N. Okay. Out of those 89 people, what was the average of their score? 267. That's my X bar, y'all. Very good. Now, look at this part right here, y'all. Look, I'm going to underline it in purple. Boom. That's my claim. It said a school administrator declared, they're claiming, okay, so let's write this out, that the mean score, mu, is more than 260. Y'all, using inequality signs, more is greater than or less than? What do you think? Greater than, look, greater than 260. Okay, I got a question for you guys. We did this on Tuesday. Do you remember, is that my ho or is that my ha? That's the ha. Okay, so remember, y'all, the ho is going to be the opposite, right? If the claim is that it's bigger than 260, then the opposite would be it has to be smaller than or equal to 260. Okay, I got a question for you guys. Let's look at part A. Let's look at part A. Can we find which was one of those is our claim? So look, y'all, I'm looking for this right here. Which one of those represents A through F? Which one represents what we wrote? What do you guys think? E? D? Is it D or is it E? Which was the claim?
Oh, sorry, you're right.
E, right? Yeah, because the claim was on the ha, right?
Yeah.
Okay, so guys, look, y'all, one thing I want to say, when we make our mistakes, let's make them here together. This is a judgment-free zone, right? And hey, look, yeah, look, D and E look really similar, except look where the claim is, right? The claim was on the ha. Very good. Okay, now, y'all, we're going to find our standardized test statistic. So this is what we're going to do. We're going to use this formula right here, okay? Look, let's see if we can find our standardized test statistic, y'all. What do we say our X bar was?
You said it was 267.
267, right? What was the mu?
The mu was
What's the claim?
260.
260, right? Good. Okay. Now, do we know our sigma? Ooh, you know, we didn't write that down earlier. Do we know our population standard deviation, y'all? 34 right here, right? Boom, it's 34. So look, y'all, 34 divided by the square root. What was our N? 89. Okay, y'all, I'm going to show you guys something. I'm going to come back over here. Boom. We're going to do this. Let me turn this guy on first. Sorry, clear this out. Y'all, the way exactly how I wrote it here on my paper is exactly what I'm going to do here. 267, right? Boom. Minus 260. Close that off. Divided by, we said 34. Divided by the square root of what? 89. Okay, close it off. Boom. All right. They're asking me to go to what? 2 decimal places? Did anybody else come up with 1.94?
Came up with 1.92.
So check your work again, because you might have made it. Did anybody else get 1.94? You got 1.94. Anybody else getting 1.94? If you're doing the calculation, 267 minus 260, 34 over the square root of 89. Yeah, 1.94. Okay. Now, what we're going to do, y'all, we're going to find the p-value. What we need to figure out, is this a left tail, a right tail, or a two-tailed test? The way we determine that, y'all, we look, my friends, always at the ha. Do you see how my arrow in the ha, y'all, points to the right? That means it's a right tail test. So let me show you what we're going to do, y'all. Boom, here's my graph, right? Look at the number we came up with in part B. Didn't we come up with 1.94? What I'm trying to find, y'all, I'm trying to find that area. Okay, I'm trying to find that area there, y'all, in the green, okay? So look, y'all, if I'm trying to find this area in the green, do you guys agree normal CDF? 1.94? Where are we going to stop if we keep going all the way to the right? What do you got? 5,000, right? Okay, let's try this. All right, second bars Number 2, 1.94, comma 5,000, 1, 2, 3. Let's close that off. Let's hit enter. Okay, y'all, I want you to notice something here. They are asking me to go to 3 decimal places. What do y'all think? 0.026 or 0.027? 26, right? Okay. Now, we got to decide, are we going to reject or fail to reject? Okay, so let's do this, y'all. Look, P 0.026, right? What was our alpha in this case?
Alpha was 0.09.
0.09, right? So let's back up.
So alpha is greater.
So yeah, I know alpha is greater, but remember the way we do it, y'all, we always ask ourselves, is P smaller than alpha or is P bigger than alpha? What do you guys think? Smaller than, right? Boom. So we're going to say P is smaller than, right? So look, y'all, I'm just going to scroll back over here real quick, right up here. If P is smaller than, then we're going to do what? We're going to reject it, okay? So look, let's come back down this way. Sorry, I'm scrolling all over the place. Boom. We're going to reject it, right? Okay. So far, so good?
Yes. Question.
Uh-huh.
Here, sir, you know how we're doing the rounding off.
Uh-huh.
Will we ever, I know it's not said, but will we ever like round off the P to make it bigger than alpha? Or-
Well, you're gonna round off the P, and then you'll determine whether it's bigger than or equal to alpha, right?
But I'm just saying, like at the end, you know how it's comparing the P and the alpha over here on the right?
Uh-huh.
You know how it's 0.26?
Uh-huh.
Easily it could be 0.3, but still be smaller. But
Yes, but notice what they're telling me to do. They're rounding it to what?
3 decimals.
Right. So put it this way: when they tell you to round, but remember, even look, let's put it this way: suppose instead of that being a 2,
Uh-huh.
suppose that was an 8, and we did round it to 0.09. Remember what the formula says?
Yeah.
As long as it's smaller than or equal to, then we're going to reject it. Make sense? Awesome, awesome. Okay. Now, y'all, before I get to this last part, part E, this is what we're going to do. Let me come back here real quick. Boom. Sorry. Let me come back this way. Because, y'all, I gave you all that other handout the other day, right? The one that I called the cheat sheet. I'm going to grab it because this is what I'm going to use, y'all, to determine what we're going to do now. Okay. So look, let's come back over here. Let's figure out where we started. Was my claim the ho or the ha? What do y'all think? The claim was which one? The ha, right? The claim was the ha. So look, y'all, I'm going to come back over here. Here was my claim. My claim was the what? The ha, right? And then what did we do? Did we reject it or did we fail to reject it? We rejected it, right? So look, y'all, I'm going to come back here. When the claim is the ha and we're rejecting the ho, we're going to say there is enough evidence to support the claim. So I'm going to come back over here and I'm going to say at 9% significance level, there is enough evidence to support the claim. Does that make sense? So y'all, using that little cheat sheet, right? That little formula sheet that we have right here, that's how I'm going to be able to make my conclusion. Okay. We said the claim was the ha and we rejected the HO, right? We rejected the ho. So when it's here, we're going to say there is enough evidence to support the claim. So here we said there is enough evidence to, and it'll say either support or reject, but we said support because that's what we got, the claim. And we're done. Sound good? All right. Look, let's try another one. And let's see if we can figure this one out. I'm going to go really slow here, y'all. Okay. In auto racing, a pit crew claims that the mean pit stop time for 4 new tires and fuel is less than 13 seconds. Okay. I'm going to start right here. My claim. We're talking about the mean. Okay. The mean. Look what it says. Less than 13 seconds. Okay, I got a question for you guys. Is that my ha or is that my ho? That's the ha. Okay. So u or mu is bigger than or equal to 13. That has to be the ho, right? Okay. All right. Let's take a look. Let's see if we know some things here, y'all. How many pit stop times did they check? How many times did they do this when they were checking all these cars? How many times did they do this? Did we know? 32. That's my N. Okay. The average of those times was how much? 12.9. Very good. Okay. Do we know what our sigma is? Do we know what our population standard deviation is? Very good. 0.19. Okay. Look, y'all, I'm going to come back. We'll do this in a minute. Let's take a look at my alpha. My alpha is a 0.01. Okay. So, y'all, first thing we're going to do, we're going to find our standardized test statistic. We're going to find our Z value. Okay. Okay, so let's do that. Let's take our numbers and let's plug them in. 12.9 minus 13 all over sigma 0.19, oops, divided by the square root of what, 32? Okay, just like we did before, y'all, I'm going to use my calculator here, okay? Let's see if we can figure this out. Look, 12.9 minus 13, okay, boom, divided by 0.19 divided by the square root of, we said, what, 32? Okay. All right. Two decimal places, y'all. Negative 2.97, negative 2.98. 98. Okay. So look, we got that number right there, y'all. Let's see where that number is on my normal curve. 1, 2, 3, minus 1, minus 2, minus 3. Look at the number we got, y'all. We got negative 2.98. Okay. We got negative 2.98. Now, I got to figure out, hey, is this a left tail test or right tail test or two tail test? Yeah, we always got to look at the ha. Look at the area, y'all. We're looking for the area to the left. So let's see if we can find that p-value, okay? So look, y'all, if I wanted to find my p-value, okay, we're going to go with the normal CDF. Everybody agree negative 5,000? All the way to a negative 2.98, right? All righty. Let's do it to it. Yeah. And y'all, like I said, and the problem we did before, like this problem, this is a question I had just made up, but the problem that we had done before, they were asking us to go to 3 decimal places. Let's go ahead and just go to 3 decimal places here. Would you say 0.001 or 002? 001. Okay. Now, let's take a look at our alpha. Okay. So my alpha here, y'all, is 0.01. Okay. Is P smaller than alpha, less than alpha? Yeah, P is smaller than alpha. When P is smaller than alpha, what did we say we were going to do? Anybody remember? Look. We're going to reject, right? Yeah. So look, y'all, let me just scroll this down here a little bit too, and we can find it. Where was it? Oh man, we had it here somewhere. Here we go. Boom. Yeah, when P is smaller than alpha, when P is smaller than alpha, we're going to reject it, right? Okay. So look, y'all, we're going to say right now, we're going to reject, okay? Was my claim the ha or the ho? The claim was the ha. Okay, so let's come back over here, y'all. Look, when the claim is the ha, and we reject it, we're going to say there is enough evidence to what? Support the claim, right? So look, y'all, I don't know if it'll let me do it, but if it does, I'll drop it right there. Boom, there's enough evidence to support the claim. That's all you got to do, right? What do you think? Are we doing okay so far? Guys, I'm just trying to follow sort of like a little process here, okay? And I'm going to show you a second way that we can go through these questions as well, okay? But let's try that. Let's try that on number 6, okay? Let's try on number 6, okay? So let's take a look here, y'all. It says, a study says that the mean time to recoup the cost of bariatric surgery is 3 years. All right. Okay, let's write out our claim. Okay. The mean time is 3. Is that my ho or is that my ha? What do you guys think? Anybody remember? That's the ho. So guys, just in case you forget, the easiest way to remember, as long as there's some kind of an equal to, so whether it's equal to or it's more than or equal to or less than or equal to, as long as there's an equal to, that's going to be the ho, okay? So then, does everybody agree that not equal to would be the ha? Okay. All right, guys, I just want to point something out here. Remember, the ha tells me whether it's left-tailed, right-tailed, or two-tailed. Do you see how it's not equal to? That's going to be a two-tailed test, y'all. Because not equal to is going to be the parts on either side. Okay, so when I'm looking at my inequality sign, right? If I had an inequality sign, I'm always looking at the ha in the direction that it points. Because this has a not equal to, it's going to be a two-tailed. Okay.
So, sir, if it's equal to, like the number 3, the whole,
Uh-huh.
let's say that was our hot, right? So then it's not a 2-tailed test?
Well, yeah, because the ones we did before, they were either left-tailed or right-tailed, right? All right, so let's take a look. We can find some things here, y'all. Can we find our N? How many patients did we look at? Anybody know? We looked at what, 25 patients? Okay. How much time did it take them to recoup their cost? 3.3, right? Okay. Population standard deviation, my sigma, my friends, what, 0.5? Okay. And population normally distributed. Let's go ahead and find our standardized test statistic, y'all. Okay. Let's see if we can do this to this. So look, y'all, right here, I'm going to write 3.3 minus 3 all over 0.5 square root of 25. All right. Let's do it to it. 3.3 minus 3 divided by 0.5 divided by the square root of 25. Boom. Let's go like that. Let's close that up. Let's hit enter. Did anybody just get 3?
Yes.
All right. Okay. So look, y'all. Here, right here, guys, is 3. Let's find that area to the right. Okay. Let's find that area to the right. If we're going to find the area to the right, y'all, so that we can get our p-value, everybody agree we're going to go from 3 to 5,000? Okay. Let's do it. Let's go here. Boom. Let's clear that out. Number 2, 3, comma, 5,000. Let's close it off. Did anybody get 0.0013, all that kind of fun stuff? Now remember, y'all, because this is a two-tailed test, remember how we're going to find P? Once we find that area, we got to double it, right? Because it's not just that area, but it's that area on the other side as well. So look, y'all, let's go ahead and go to 2 decimal places. 0.002 or 0.003? Yeah, so P 0.003 alpha, what was it, 0.01? Okay, is P smaller than, bigger than alpha? What do you think? Smaller than, right? So look what we said, y'all. When P is smaller than or equal to, we're going to do what? We're going to reject it, right? Okay, so look, let's come back over here. Okay, because P was smaller than alpha, we're going to reject it, okay? Now, I got a question for you. Was my claim the ha or was my claim the ho? What do y'all think? The claim was the ho. Okay, look, guys, let's come back over here. If the claim is the ho, but we rejected it, look what we're going to say. There is what? There is enough evidence to reject the claim. So right here, y'all, we're going to say, boom. Oh, man, that's not where I wanted to do it. We'll put it over here on the side, maybe. It lets me. There we go. There's enough evidence to reject the claim. Does that make sense? So, y'all, that little cheat sheet, that little formula sheet, the last time I taught this class, y'all, I use that all the time. I use it all the time to figure out what we're going to do from there, okay? All right. Let me keep moving down, y'all. Charlie Brown, let's keep moving down this way. I got another question here in my homework, y'all.
So,
Tell me.
one quick question again. Going back to the whole.
Uh-huh.
We have an equal sign.
Yes.
No matter if it's the whole or the ha, as long as it has an equal sign, it's a two-tailed test.
So remember, this was the ho because it had what sign?
The equal sign.
The equal sign,
Yeah,
right?
I understand that.
Okay, so what's the opposite of saying something is equal? Saying that it's what?
It's not equal.
Not equal. Not equal is always going to be a two-tailed test.
So, okay. I thought it was the whole. It was telling me that it was equal to, and that's why it was a two-tailed test.
It's, well, so think about it this way. Remember when we did the problem before? Here we go.
Mm-hmm.
Okay, not that it was the claim, but the ha tells me, do I have a left or right tail test? Look at my ha. See how it's pointing to the left?
Yeah.
That's what's a left tail test, right?
That one's-
When we did this one over here, let me see. See how my ha is pointing to the right? Right tail test, right? So when it's not equal to two tail test.
two-tailed test. Okay.
Yeah.
So,
Better?
I just thought that the whole giving me an equal test was always going to tell me it was a two-tailed test, but it
Oh.
has nothing to do with that.
That's right. That's right. Okay, so take a look, y'all. Here it just says, can we match the p-value with the graph that displays the area without doing any calculations? Okay, so let me ask you a question, y'all. Look at the area, look at the pictures here, and I know y'all's copies are gray and grayer, but if you look up at the screen, just so you can see the blue, which area is bigger, A or B? B is bigger, right? Okay, then let me ask you a question. Which one of those numbers, I'll put it this way. Let's do it like this. Again, I know you can't see, if you're looking at yours, you can't see it. Which one of those numbers is bigger, the red or the green? What do you think? The red is bigger, right? Okay, so if the red is bigger, then wouldn't the red be B right there, right? And then wouldn't that one have to be A? Because the p-value shows the area in the shaded part. Okay, it's going to be something like that, the area in the shaded part. Okay. All righty. So, y'all, let me keep scrolling down here a little bit. Okay, we're going to talk something, y'all, about something we call rejection regions and critical values. Okay. So, let's see if we can figure this thing out. Rejection values and critical values. It says a similar way to figure out whether we're going to reject or not reject is doing something called a rejection region. Guys, I'm a big fan of the rejection region. I think it illustrates the idea a little bit easier, but you guys tell me what you think when we're done. It says a rejection region or a critical region of sampling is a range of values for which the null hypothesis is not probable. Okay, we're going to find critical values. So how do we find critical values? We got to know our alpha, the level of significance. We got to know whether the test is left tail, right tail, or two tail test. The way we find our critical values, if we have a left tail test, the critical value is the z-score that corresponds to the area alpha. If it's a right tail test, it's going to be 1 minus alpha. And if it's a two tail test, y'all, it's going to be the z-scores that correspond to half of alpha and 1 minus half of alpha. I'll show you what we mean by this. Okay. So, y'all, it's going to be kind of funny because the way MyLab does this, they're going to ask you to find the critical values, and then they're going to ask you to draw the picture. I think it's much easier to draw the picture first. Okay, so look, I'm going to kind of do it like this, y'all. Look what they're telling me to do. What kind of test is it? I know, but what kind of test? Left tail test. Y'all, that means I'm looking for the area which way? There you go. So look, I know it's kind of backwards. To me, they should give me the picture first, okay? But what they're telling me, y'all, is that area there is 0.02. What we want to do is we want to find that z-score. The way we find that z-score, y'all, let's go like this. We're going to go second bars, but we're going to go to the inverse norm because the inverse norm will tell me what is the z-score when the area to the left is 0.02. So my z-score, y'all, if we go to 2 decimal places, what do you think? Negative 2.05 or 0.6? 0.5. Boom, there we go.
Sir, okay. I've noticed I use that on my work study.
Uh-huh.
The thing is that sometimes it doesn't work, and it doesn't work with the ones that, like, when it's a two-tail test.
I'll show you in a minute. Yeah, I'll show you in a minute. Okay, let's take a look. Now, what do we have here? Left tail test, right tail test? What do you think? Right tail test. Okay. So look, y'all, let's do this. Here's my right tail test. The area over here is 0.01. Does anybody know what area would be there? Anybody got an idea? What do y'all think? How would I find the area to the left? Anybody remember what the total area was? It's 1, right? Yeah. So look, if we go 1 minus 0.01, isn't that 0.99? Okay. Now, the reason I want to know that, y'all, is because look, when we go second bars and we go to inverse norm, number 3, we're going to enter in 0.99. Why are we doing that? Because the inverse norm always tells me the area, y'all, to the left. Look, my z-score is going to be a positive something. 2.33. There you go. Oh, come on.
That's what it was doing. And I was like, why isn't it working?
Sorry, guys, my pen is freezing up here. There we go. 2.33. Okay. So look, y'all, when we find this like this, let me draw a better picture. That picture is a little messy. 0.01. This area is my fail to reject, and this area is my rejection area. Okay. So look, y'all, here's my 2.33. We're looking for the rejection area. Okay. See how they told me it was a right tail test? Then my rejection area is when Z is bigger than 2.33. Okay. Z is bigger than 2.33. Okay. And did they give us a picture? Oh yeah, they did. Guys, look at the picture we drew and look at the 4 choices they're giving us. Which one is the one that has the rejection area? I'll do this just so you can see a little bit better. Which one looks like, yeah, D, right? Boom. And there's my answer. Okay. All right. Let's do this, y'all. We're going to go real slow here. Okay. All right. Let's find our critical values and rejection areas for what we call the type of test we got here. Look what we have, y'all. We got a two-tailed test. Okay, so this is what you're asking about right now. Okay, y'all, let me ask you a question. If it's a two-tailed test, before I even get to the first part, look at the pictures. Which of those pictures, A through D, looks like a two-tailed test? B. You see, that's what I said, y'all. It's kind of funny because in my lab, they ask you to find the values first and then they give you the picture. But I think it would be so much easier if we had our picture first and then we can say, look, it's a two-tailed test. So let me show you what we're going to do. Do y'all see how the alpha here, y'all, is 0.02? Because that alpha, that's over both pieces. So that means that this area in those spots, y'all, is actually 0.01. So look, if I wanted to find those z-scores, do you guys agree they're going to be the same number, but one being positive and one being negative? Okay, look, how would I find the area to the left here? We're going to come back, use our calculator, y'all. We're going to go inverse norm, but the area to the left, everybody agree, 0, 1? Right? Because it was, remember, alpha was 0.02, but we got to cut it up into those two pieces, right? So the area to the left here, y'all, is 0.01. Look, what do you think? Negative 2.32 or 33? What do y'all think? 33. Okay, check this out, y'all. So right here, you're going to put plus and minus. Oh. How do you do it backwards?
Oh, I think I did backwards because I got the 01 and then I did 1 minus 01 and I got the right side.
You got, but you're making it harder to do. You see what I'm saying? You're making it more complicated. Yeah. Now look, y'all, these are my rejection regions. This is my fail to reject. So look, the rejection regions is when I'm less than 2.33 or bigger than 2.33. Okay. All right. Let me scroll down a little bit, y'all. Let's see if we can figure out what we're going to do in these questions, okay? So look, y'all, this little chart here kind of just gives me a picture of how do I know what's my rejection region? How do I know what's my fail to reject region, okay? So in a left-tailed test, the area to the left is reject. It's on the right side if it's a right-tailed test, and it's on the ends if it's a two-tailed test. Okay, let's see what we're looking at here, y'all. Okay. I'm going to go through really slow, y'all, and we're going to answer these questions. It says, a company that makes cola drinks states that the mean caffeine content for a 12-ounce bottle of cola is 40 milligrams. Okay, look, y'all, I'm going to stop real quick. Their claim is that the amount of caffeine we're going to get in a soda is how much? 40. Okay, I got a question for you guys. Is that my ha or is that my ho? That's the ho, right? Everybody agree not equal to 40 is going to be the ha? Okay, guys, before I do anything else, that's a two-tailed test, right? Okay. Look at my choices, A through F. Which ones have that? Where the ho is equal to 40 and the ha is not equal to 40. What do you guys think? E. Boom. So far, so good? Okay. Now, I'm going to show you guys something. I'm going to draw a picture here, y'all. There's my normal curve. I know it doesn't look all that great, but that's just how I draw. Okay. Y'all, look at this case. My alpha was a 0.01. What we need to do, y'all, is we got to take that number, 0.01, we got to cut it in half. So the area over here is 0.005, and the area over there is 0.005. Okay. Y'all, look at the way we drew our picture. Okay. Am I going to get one answer for Z, or am I going to get two answers for Z? Two answers for Z. Okay, let's see if we can find that, y'all. Look, we're going to go inverse norm, but the area to the left is a 005. Okay. Is anybody getting negative 2.58? Okay, so look, y'all, remember, one's going to be negative, one's going to be positive. So right here, y'all, we're going to put 2.58. We're putting that in there for B, y'all, because that has a little plus and minus in front of it. Okay. All right. Look at the picture I drew. It's ugly, right? The one in red and black, it's ugly. But look at the pictures that they're giving us. See? Boom. Because it's a two-tailed test, right? Okay. So now this is what we're going to do, y'all. So I'm going to do this just to give us an idea. Negative 2.58, positive 2.58. Y'all, let's see if we can find our standardized test statistic. Okay. I'm going to write down the formula here, and we'll figure it out. Okay, I got to go back and read my question again. Man, I already lost a whole bunch of stuff because I didn't read all my question. Okay. Let's see, y'all. We need a couple of things. We need our N, we need our X bar, and we need our sigma. Okay, I'm going to try to put all of this on the same page just so I can read it. All right. We want to test this claim. We take a random sample of how many? 30. That's my N. Okay. And we find that the mean content of caffeine was actually how much? 37 and a half, right? Did we know our population standard deviation? There you go. Okay, let me zoom back out. Look, y'all, we're going to do that right here. X bar, 37.5. What was our mu? 40, right? Boom. Divided by sigma, 6.9, divided by the square root of 30. Okay. Let's crunch some numbers, y'all. 37.5. Okay. Minus 40. Okay. Divided by, what is it, 6.9? Mm-hmm. Divided by the square root of what number? 30. Okay. Boom. Let's go like this. Let's hit equals negative 1.98. Okay. So this is what we're going to do. All right. Now, guys, I'm going to zoom in real easy right here. Okay. See how that 0, isn't that 1, 2, 3, right? That's negative 1. That's negative 2, right? What number did we come up with right now? Negative 1 point what? Negative 1.98? Mm-hmm. Sorry. What area did we fall in? Did we fall in? Look at the picture up here, y'all, just so you can see what I'm looking at. Did we fall in right here? Did we fall in the reject, or did we fall in the fail to reject? Fail to reject. Okay. So we are going to fail to reject. So look, y'all, I'm going to go like this. FTR, fail to reject, right? But I got to figure out, look at my choices here. Z is not in the rejection region. So we're going to fail to reject, right? Because we're not in the rejection region. That's choice A. Okay. Now, we got to figure out how are we going to answer the last part. Okay, let's do this real quick, y'all. Come back over here. Oh, let me come back actually to the top. Was my claim my ho or my ha? The claim was the ho. Okay, so let's come back over here. The claim was the ho, and y'all agree we failed to reject?
Yes.
So look what we're going to say, y'all. There is what? Not enough evidence to reject the claim. So look, y'all, right here. We're going to say there is not enough evidence to, what do we say? Reject the claim that a 12-ounce bottle of cola, I think it's going to say has or is, was in it 40?
Yes.
There you go.
So, quick question.
Mhm.
Then the 1.98, is that a threshold?
That's our test statistic. That we're going to figure out where does that number fall
Uh-huh.
compared to that picture. Do we fall in the reject area? So are we on the outsides of the 2.58 or whatever number we got? Or are we on the insides? And weren't we on the inside?
Yeah, I saw that. I like how you put it, but and when you're doing this, it doesn't tell you. So that's like kind of like. Okay.
Yes, very
I'm just
good.
wondering what the 198
Yeah, no, definitely. And guys, look, let me show you guys something. There is a way that you can do some of this on the calculator. Okay. And I'm going to show you how to do some of this on the calculator. Now, look, y'all, when I was doing the first part, that's not calculator work. That's me reading. Okay. Now, if I wanted to find my critical values, is there a way for me to find it on my calculator? I mean, we really did use our calculator, right? Because didn't we do the inverse norm here? What I'm going to show you guys is how can you find this number on your calculator without you actually having to go through that number crunching, okay? This is how you can do that part. Let me clear everything out. Look, guys, I'm going to go to went to stat first. Let's go to test. And let me see where it is. Right here, number 1, the z-test. Let's hit enter there, okay? We're not going to use data. We're going to use statistics, okay? Now, what was our mu in this case? 40. Let's put a 40 right there. Boom. Okay. What was my sigma? Does anybody remember what our sigma was? Look, I'll put it up here so you can see it. Yeah, 6.9, right? So look, let's put a 6.9 right there. 6.9. Let's see. Oh, it's supposed to be under stats. Sorry, guys. Let me come back up here. Stats, enter. There we go. Okay, 46.9. What was my X bar? 37 and a half. Okay. Okay, what was my N in this case? 30. Okay, now this part is really important. Y'all, did we have a left tail, right tail, or two-tail test? Okay, I want you to notice something right here. See how it's not equal to? That's two-tailed, okay? So we're going to make sure we're not equal to. Look, y'all, we're going to go to calculate. Boom. I want to show you guys something. Look at the z-score we got right there at the top. Negative 1.98. Is that the same number we got? Okay. Now, y'all, the last time I taught this class in person, right, with people in front of me, like the way you guys are, was in 19, right? What I was, and guys, I'm not making any judgments here. What I'm telling you is when I do the z-test, you know what really what the z-test did for me? The z-test did that calculation, okay? That's really what it did for me. It did this calculation right here because that was a number that we got, right? And then we figured out we were in the fail to reject zone. So it's up to you. You can use the z-test. With the everything else, I still had to kind of write stuff out to figure where I was. But the z-test will do this calculation without me having to do it. Now, when I taught this class in 19, that was 6 years ago. Some of y'all were like in 8th grade or something, right? But when I taught it in 19, some people were like, hey, sir, that's enough for me. I'm good with that. I'll use that because I don't want to have to do this. And some other people were like, I can do that too. It's not a big deal. Whatever you decide, y'all, it's fine with me. Okay. Whatever way is easier for you guys to do. Yes.
I see that it also gives us the P. So
It gives me the P, but look here in this question. So I can figure out, so it does give me the P. What was our P value here?
P04.
Was 0.04, right? Okay, so what was the alpha that we had in this case?
0.01.
So was P bigger or smaller than alpha?
It's actually
Greater than alpha, right? So look, let's come back here real quick. What do we say if P is bigger than alpha, did we say we were going to fail to reject? Isn't that what we did? We failed to reject, right? Okay, so you'll say we're gonna, it's not in the rejection region, so we're gonna what? Fail to reject, right? You're still gonna do that part. So yeah, you can do it like that too. You can definitely do that. Look, y'all, I think we just got 2 more questions, y'all. Let's do these last 2, and then we'll call it a day, y'all. Okay. And again, I'm going to try to make this, y'all, so that it's hopefully easier than more difficult. Okay. Let's read together, y'all. Remember we're in school, right? Back like in high school, maybe junior high. And I'd say, okay, Paulo, you want to start reading the first sentence? And then Abraham, okay, pick up where, remember that? Remember y'all when you're all in school? Okay, now I'm not going to do that to you guys. All right, just, huh? She does that? Sometimes. All right, let's go through it, y'all. Look, it says a fast food restaurant estimates the median sodium content in one of its breakfast sandwiches is no more than 930. Okay, look, y'all, this is what I'm going to do. I'm going to write some stuff here. This is my claim. We are talking about the mean, which is the mu, right? The funny looking u. I got a question for you. No more than 930. What does that mean in terms of an inequality? No more than 930. Does that mean more than 930? Less than 930? What do you think? What do you think? No more than. No more than, right? So, look, I guys, I told y'all a long time ago, I used to smoke cigarettes, right? I don't quit smoking cigarettes anymore. I quit. But my girlfriend at the time says, hey, I don't want you smoking more than 10 cigarettes today. No more than 10. So if we don't want no more than 10, what does that mean? Smaller than or equal to, right? Okay. So look, y'all, smaller than or equal to, what are we saying? 930? Okay. That's my claim. Now I got a question for you all. Is that my ho or is that my ha? That's the ho. So then mu is bigger than 930. That's got to be the ha, right? Okay, I got to ask you a question now. Look at my choices, A through F. Which one looks like what we got here? A through F. Which one of those choices looks like what we wrote up there? D. Boom. Okay. Now, second question, guys. I got a question for you guys. I'm going to draw a picture. Before I even do my critical value, I'm going to draw my normal curve. Okay. What do you think? Left tail, right tail, or two-tail test? I'm sorry? Very good. Look, y'all, this is a right tail test. The alpha in this case, what, is it 0.05? Okay, now y'all remember, I'm trying to find that critical score right there. Okay, that Z value. My question to you though, does anybody know what would the area on this side look like? How much would that area be? Very good. 1 minus 0.05. Everybody agree? 0.95? Okay, look, let's see if we can find our test statistic, y'all. Our critical value, I'm sorry. Let me turn this guy back on. Let's clear it. Okay, let's go second bars. We said the area to the left was what, 0.95? Okay. We should be getting a positive answer. Guys, 1.64? Right? Boom. Right here. 1.64. Okay. So look, y'all. That's my rejection region. This is my fail to reject region. Okay. Now, because this is a right tail test, the rejection region is going to be the one that points to the right. Okay. All right. Now, let's do part C. Look, guys, they're actually even telling me on this question, they're telling me use technology. Look, why don't we try the little testing on our calculator? Okay, let's do this before we do the testing. Before we do the thing, let's find out some information. Okay, N. How many breakfast sandwiches did they look at? 34. Okay. How much? What was the average sodium in those 34? Anybody know? 922, right? Boom. Okay. What was my population standard deviation here? 23, right? Okay. And remember, y'all, we said our mu in this case was what, 930? Okay. But instead of me going through the whole, let me do the Z thing, let me use my calculator, right? Let's come back here. Look, guys, I'm going to clear this thing out. I'm going to go to stat. Boom. I'm going to go to test. We're going to do number one, the Z test. Okay. We're still going to be using stats. Okay. Come on. Yes. Okay. Stats. Boom. Let's go down. Okay. My mu in this case, we said mu was 930. Okay. Let's fix that. 930. Boom. My standard deviation, y'all, was 23. Okay. My X bar, y'all, was what, a 922? Okay. And my N was a what, 34? Okay. Next question. Before we go on, y'all, did we have a left tail, right tail, or two tail test here? We had a right tail. Look, y'all, we're going to go to the third one. See how it's pointing to the right? We're going to go over here. See how that one's pointing to the right? That's one we're going to hit. We're going to hit enter right there. We're going to go to calculate. Boom. Look at my Z score, y'all. I'm coming up with a negative 2 point, what do you think? 0.2 or 0.3? 0.3. Okay, so right here, y'all, boom. We're going to put a negative 2.03. Okay. Now, I'm going to draw my picture one more time, y'all, because it was a little messy. Let's see. That is reject. This is fail to reject. Look where that number would be, y'all. Are we falling in the rejection area or are we falling in the fail to reject area? Fail to reject, right? Boom. Awesome. Very good. Okay. Second question, guys. Was my claim the ho or was my claim the ha? The ho, right? So look, if you're wondering, y'all, we had already picked choice D, right? We said, look, my claim was the ho, and we fell in the fail to reject region. Look, guys, I'm going to come back over here again. My claim was the ho, and we failed in the fail to reject region. So we're going to say there is not enough evidence to what? Reject the claim, right? Boom. We're going to go here. And I'll just drop it right over here where we got a little bit of room. Boom. And you're done. Does using that little test thing on the calculator help? It helps, right? It's one less calculation you got to do. Okay. Y'all, the one thing you just got to be careful of is when you're entering your numbers in, right? One small mistake, like, oh man, I meant to put 23 and I hit 2.3. Boom, it throws the whole thing off. Okay. All right, look, y'all, we got one last question. Oh, I know it's a lot. I know, but we're almost done. I think I'm pretty confident. Yeah. Look, guys, last question here. Okay, let's knock it out so that we are done. Okay. Okay. We're going to read together. Now I'll read it for you guys. A light bulb manufacturer guarantees that the mean life of a certain type of light bulb is at least 771. Okay. So what does it mean at least 771? Does it mean 771 or less or 771 or more? More or more. Very good. Is that my ho or is that my ha? That's the ho, right? Boom. Okay. Okie dokie, y'all. Let's pick A through F. Which one has what we wrote? What do y'all think? Mu is bigger than 771 is the claim, which is the ho, and mu is smaller than 771, which is the ha. What do you think? A through F. E, right? Boom. Y'all, I could have stayed home today. You already know what to do. Okay. Second question, guys, what do you think? Left tail, right tail, two tail test. Look at the ha. A left tail test. Okay, so look, y'all. I know there's pictures there, but I'm going to go ahead and draw my own right here. Boom. Okay. Look, what did they tell me an alpha in this case? Did they give us a number for alpha? 0.08. Look, y'all, that is my area right there. Let's find that critical value. Okay. Guys, remember, I'm still going to use my calculator here. Still going to go second bars. Still going to go inverse norm because we're already looking for the area to the left. We don't got to do much. Okay, question, guys. What do you think? Negative 1.40 or 41? 41. Awesome. Negative 1.41. Look, y'all. That is reject. That's failed to reject. Okay, so look, we already drew the picture, but you already know what the picture is, right? What do you think? A, B, or C? B, right? Boom, because that picture and that picture, igualitos, right? The same. Okay. Now, let's see if we can find our standardized test statistic. Oh, man, we got to find some things first before we can do that. Okay. Let's see if we can figure some things out here, y'all. Okay, we already know that mu is 771. Okay. We got to find N. We got to find X bar. We got to find sigma. Okay. Oh, man. Do we know what N is? How many light bulbs did they look at? 30. Okay. What was the average life of those light bulbs? There you go. And my standard deviation? There you go, 57. Boom. Okay, let's do it. Let's clear this out. Let's go to stat. Let's go to test. Let's do number one. Okay, we're still going with stats. Okay, mu was 771. Okay. 57 was my population. My X bar, we said, was 754. Our N was 30. Guys, question. Left tail, right tail, two tail test. What was this? Look at it right here. Look at the picture. Left tail. Look, y'all. Which one points to the left? See that right there? We're going to go here. We're going to go here. We're going to hit enter. Then we're going to hit calculate. Boom. Okay, guys, for your Z-score, did anybody get negative 1.63? Okay, let's write it down. Okay, I want to show you guys something, y'all. The number that we came up with here, negative 1.41. Okay, the first time we did this, we got negative 1.41. My question to you, negative 1.63 compared to negative 1.41, is negative 1.63 to the left or to the right of 1.41? To the left. What area did we fall in? We fell in the what? Rejection region? Okay. Now, guys, before I pick my choice, A, B, C, or D, okay, before I pick my choice, let me scroll back up again. What was my claim? Was my claim my ho or my ha? The ho, right? Let's come back here. The claim was the ho, and we rejected it. So what are we going to say? There is enough evidence to reject the claim? So look, y'all, let's look at that. We are in the rejection region. So there's two. There's choice A and there's choice D. Which one says there is enough evidence to reject the claim? A. Boom. And you're done. Okay. Question, guys, before we leave. You like that Z-test? Makes it a little bit easier to do. And guys, like I said, you know what it's really doing? It's just doing that one calculation. But hey, these problems, you can see they're long problems to do, right? And hey, that one calculation, man, if it makes it easier, breezier, cover girl, by all means, y'all, let's do it. Okay? By all means, let's do it. All right. So guys, just again, before we leave, I mean, that's the last question, but before we leave, y'all, I've changed the deadline here. Let me fix that. But I did change the deadline to the 22nd, y'all, because we're not here in school next Thursday, right? So Tuesday, y'all, when we come back, we're gonna do 7-3. Guys, we're gonna finish up chapter 7 the next week. So one of the things I'm gonna start working on, guys, I'm gonna start getting the review for the third test ready, okay? Because our third test will be over chapter 6 and 7. Probably won't be very long. It's only like 7 sections, and we'll figure out what we're gonna do the rest of the semester, okay? But next Tuesday, guys, 7-3. And then we only got one more section to do out of chapter 7, 7-4. And then we'll figure out what we're going to do after that, okay? But that is it for us today, guys. We are done. Thank you all for showing up. I appreciate it. Those of you who are online, I appreciate y'all being here too. Okay, that's no problem. Don't worry. Let me go ahead and hit stop recording.